All right, so in this lesson, we are going to talk about ordering fractions. Ordering fractions is not a complicated process, but it is a long process. So it's important not to try and take any shortcuts while we order the fractions. All right, so let's go ahead and get started. Before we get started, let's do a quick review on ordering some basic integers. So let's order these numbers from least to greatest. So remember with negatives, with negatives, the biggest number is usually the smallest. So we have -8, then we have -2. Now we have all positive numbers. So we're going to go 1, 3, and then 10. Okay, now we're going to go reverse. We're going to go greatest to least. So we'll start with our positive numbers, 15, 9. And now we're going to dip into our negative numbers, -1, -3, and then -4. Just a quick review to sort of get our mind into ordering. So how are we going to order fractions? So we're actually going to order fractions in a very similar way that we order negative integers. But before we can do that, we have to get them all so that their denominators are exactly the same, so that we can look at the numerators and just order the numerators. So the first thing that we need to do is we need to focus on the denominators, and we need to find a common denominator. So by looking at these bottom numbers, 12, 4, 6, and 3, we need to find the LCM for that set of numbers. Now, by this point in the school year, we could make our factor trees and find the LCM, but these numbers are pretty low enough that we should be able to find the LCM off the top of our head. And the LCM for this is going to be 12. So now that we have our LCM of 12, what we're going to do is we're going to write an equivalent fraction with a new denominator. So below this, I'm going to make a new fraction. So I have a new denominator of 12 for each of these. So this guy this guy here already has a denominator of 12. So I'm going to leave him alone. Now, how many times does 4 go into 12? 3 times. So 3 times 1 is 3. How many times does 6 go into 12? 2. So then 5 times 2 is 10. How many times does 3 go into 12? 4. Okay, so then 2 times 4 is 8. So now we have a new set of fractions. Now that we have that, we need to go ahead and order them, but we need to order them based on the original fractions. We cannot order them based on these new equivalent fractions because our answer choices on things like a test or a quiz or on the EOG are going to be with these fractions. That's why dating back all the way to things like, I'm trying to remember when we had you use original numbers. Like when we were talking about ordering integers and we had absolute value in there, we had you keep the absolute value bars in there. Because when we give you answer choices, we're using the original numbers. And so it's very, very important that you keep the original fractions in the answer. So I'm going to rewrite these down in the next slide real quick. 7, 3, 10, and 8. 7, 3, 10, and 8. And now we are just going to go ahead and order them. So let's just go ahead and order them from least to greatest. Okay, so all we need to look at now is this top row right here, which are our numerators. So what is our least number? Well, it should be this guy right here, 3. And if you line them up very nicely with your original fractions, it should be very easy. And you can always do something like this. You can write, okay, this guy's going to be number 1, and then X him out. Who's going to be next? Okay, this guy's going to be number 2, X him out. Okay, this guy's going to be number 3, X him out. And then this guy's going to be number 4, X him out. So now, let's go ahead and order them. So we're going to have 1/4, 7/12, 2/3, and 5/6. It's not a hard process, but it is a lengthy process. So let's go ahead and do example number 1. All right, so we are ordering from least to greatest. Let's look at our denominator. 2, 3, 9, and 6. What would our LCM be? Okay, you should have come up with an LCM of 18. Okay, so what we're going to do is we're going to make new equivalent fractions. Here's 18, 18, 18, and last but not least 18. Okay, now how many times does 2 go into 18? 9 times. So 1 times 9 is 9. How many times does 3 go into 18? 6. So 1 times 6 is 6. How many times does 9 go into 18? 2. So 7 times 2 is 14. And then how many times does 6 go into 18? 3. So 5 times 3 is 15. Now all that's left is we have to go ahead and order them just based on this line right here, the numerators. So this guy is going to be first. This guy's going to be second, third, and then fourth. So let's go ahead and order them. We're going to have 1/3, 1/2, 7/9, and 5/6. That was a lot quicker than the first example. So once you get into the groove of it, it will be a lot quicker. Let's try example number 2. So again, let's look at our bottom numbers here, our denominators, and let's try to think of what our LCM would be. Here's an easy way to do it. Look at 25. Do all of these numbers go into 25? No, because 4 and 2 don't. All right, what's the next multiple of 25? 50. Does 4 go into 50? No. What's the next multiple of 25? 75. Does 4 or 2 go into 75? No. What's the next multiple of 25? 100. All of these numbers go into 100. So the LCM is 100. So go ahead and set up your fractions with a denominator of 100. And then let's go ahead and start to make them equivalent. 4 goes into 100 25 times. So 3 times 25 is 75. 25 goes into 100 3 times. So 1 times 3 is 3. 5 goes into 100 20 times. So 2 times 20 is 40. 2 goes into 100 50 times. So 1 times 50 is 50. Now let's go ahead and order them. Our instructions tell us to go from least to greatest. So this guy's going to be 1, he's 2, 3, and 4. All right, so we use original numbers. 1 over 25, 2 over 5, 1 over 2, and 3 over 4. And again, all I was looking at were these blue numbers. And I can do that because all my bottoms are the same. All right, let's take a look at example number 3. I'm just looking at the denominators, and as I look at them already, my LCM is just slapping me in the face, and it should be slapping you in the face too. We should have an LCM of 10. Our bottom numbers should be 10. We need to find a common denominator, okay? So, how many times does 2 go into 10? 5 times. So 1 times 5 is 5. How many times does 5 go into 10? 2 times. 4 times 2 is 8. How many times does 5 go into 10? 2. So 3 times 2 is 6. How many times does 10 go into 10? 1. So 7 times 1 is 7. Now let's go ahead and order them. So 5 is first, 6 is second, 7 is third, and 8 is fourth. Now let's use our original fractions. We're going to go 1/2, 3/5, 7/10, and 4/5. And I think that was the quickest one yet. So again, it's not a very quick process, but as you practice, it does get much quicker. All right, let's take a look at example number 4. I'm going to circle my denominators. So I have 8, 4, and 10. Okay. So I need to think here for a minute. All right, so I have 10, 20, Okay, 4 goes into 20, but 8 doesn't. 30, nope. 40, okay, 4 goes into 40, 10 goes into 40, and 8 goes into 40. All right, so that must be it. So 40, 40, 40, and 40. All right, so 8 goes into 40 5 times. So 3 times 5 is 15. 4 goes into 40 10 times. So 1 times 10 is 10. 10 goes into 40 4 times. So 8 times 4 is 32. 8 goes into 40 5 times. So 1 times 5 is 5. Now let's go ahead and order them up. So it looks like this guy's first, he's second, she's third, and then this one is last. And we're going to always use our original fractions, and we're looking at this blue line right here. So we're going, oh, oops, 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 I did not even follow my own directions. Oops, and I messed up on the last one too. We got to go back to the last one too. We were going greatest to least. I was so excited. Oh no. Okay, let me finish this one. Oh no, oh no. Okay, let me back up a little bit here. So, we're going greatest to least. I was not even following my own directions. Greatest to least. So my biggest. So this is 1, this is 2, this is 3, and this is 4. Okay, I got it now. So we use original fractions. So 8 over 10, 1 over 4, 3 over 8, and then 1 over 8. And I need to go back to example 3. Please go back to example 3. We did almost everything right. We just have them backwards. We did them least to greatest. So we need to do them greatest to least. So this is 1, 2, 3, and 4. All right. So here we go. We have, let's see, 4 over 5, 7 over 10, 3 over 5, 1/2. All right, now we are in good shape. Okay, so for ordering fractions, the best way to practice is to go back to comparing fractions and then to also practice ordering fractions. And the best place that I've seen to do that is actually on IXL. And so your practice work is 2 IXLs in 5th grade and then also 2 IXLs in 6th grade. And so that's what I want you to work on. So that is actually the end of this lesson. And my dog is barking and she's bringing me a squeaky toy, and so we're going to stop the lesson here and we're done anyway. Ask me any questions you have in class.